Hello everyone. So in this video I'm gonna explain you guys about errors and artifacts with some examples, and I hope you understand what I meant to say in this video. So let's get started with the video. Errors and artifacts and imputation. So in the realm of data quality, it is imperative to distinguish between different types of anomalies as their origins dictate the appropriate remediation strategies, where errors are human made or mechanical failure, or artifacts are semantic processing anomalies. So errors are human made and mechanical failure, where human can make a typo error while entering the data into the table, or he can make a bad decision of choosing a data from a misleading site, and that misleading data can skew your analysis. And a sensor malfunction can also mislead your readings or anything that you are having. So sensor malfunction, here's an example which says thermometer records 0 degrees at summer heat wave. That's completely skewed, right? So humans are not the one who is responsible for the errors. Mechanical machines are also a part of producing errors too. Yeah, to prevent errors, a person who is working, analyst who is working with the data should rely on highly first person data, which from the first party data that is produced by their own company, or the source which he has referred is a very reliable one. So it is up to a human analyst who is choosing the right thing for for their analysis. And the sensor errors, just replace the sensor, buddy. Then comes the artifacts, systematics, processing anomalies. Unlike errors, artifacts are not faults of the source, but rather a byproduct of the processing pipeline itself. These are systemic anomalies introduced during data transmission or inversion or conversion, such as a pixelation glitch seen in a compressed JPEG image, or character encoding issues when moving text between operating systems. So unlike errors, artifacts are not faults of source but rather byproduct of the processing pipeline itself. These are systemic anomalies introduced during data transmission or compression, such as pixelation glitches seen in compressed images. When you saw a picture which is highly pixelated, like it's not processed properly, it's a artifact. Like it's an error. It's an error of systematic processing. Like uh, like picture is not cleared. It's very pixely, and the color is not correct, and it's very contrasting. So it's a problem of system, the sensor or something, or character encoding issues when moving text between operating systems. So what are the techniques for data imputation? So when facing the inevitable challenges of missing values, simply discarding data is often not an option. Instead, analysts employ imputations, the statistical practice of replacing missing data with estimated values. Here comes the role of mean median imputations, where this is a fundamental technique where missing entries are replaced with the central tendency of the data set. For example, if a student test score is missing, one might insert the class average, that is mean, or middle score, that is median, to maintain the dataset size without significantly skewing the distribution. Then comes the role of KNN, that is K nearest neighbor imputation, where a more sophisticated algorithm approach finds the nearest neighbor data point that are most similar to the one with the missing value. By averaging the value of this similar neighbor, KNN provides a highly educated estimate that accounts for the specific context of the missing data point, rather than just using a global average. That is from my side. Thank you for watching this video. I hope you understand what I meant to say. Thank you for watching.